Okay, so here's part 2 of the Pythagorean theorem notes. We're going to start off with another example since we want to check to make sure you're getting the idea here. Basically here, what I want you guys to do is right off the bat, pause the video, go ahead and try to find the value of x, including whether it's a hypotenuse or a leg, and solve for that. So go ahead and pause, hit play when you're ready. Okay. Drawing an arrow straight out, you're going to see that x is in fact our hypotenuse. So therefore my equation is going to be 4 squared plus 8 squared equals x squared. Simplifying, 16 plus 64 equals x squared. Adding those up, you're going to get 80. We obviously do not know what the square root of 80 is, so the best we can do is kind of give an idea of what it's in between. 81 is 9 times 9, so it has to be less than that, so it'd be between 8 and 9. Okay, so what we're going to do now is we're going to look at some word problems. Word problems. I hate them, right? No, I'm sorry. You're in geometry now. It's time to at least have a comfort level with word problems. These are going to be pretty simple. Pythagorean theorem word problems are simple because you know you're looking for a right triangle. Now, if this was a random word problem and you didn't know it was Pythagorean theorem, how would you know? Well, hopefully a picture would help. So my recommendation is read the problem, and if it calls for something that could be a visual of a picture, do that. First of all, I see the word house. Okay, so I'm going to draw a house. It doesn't have to have doors and a window. I guess I'm a little bit of an overachiever, but you want to draw a bit of some example of a house. Second thing I notice is it says how tall is the house, so I don't know how tall the house is. So that's going to be my x. You don't have to label that now. You could finish your picture and label the parts you do know, like the ladder and the distance away, and be left with the height. But if you do know, as soon as you know, I like to label things. Next, we have a ladder. That's what a ladder looks like, but not a ladder leaned against a house. That looks more like that. So we know the length of the ladder is 17 feet. We also know the distance that is away from the base, 8 feet. All of this is pulled directly out. Now, as you guys know, we are only allowed to use the Pythagorean theorem if it is a right triangle. So the question is, how do I know if that's a right triangle? Well, first of all, houses are built straight up and down. Okay, we wouldn't build houses at a slant because then everything would roll all around when you put it on the ground. So this house is going to be 90 degrees. I know I told you not to assume that, but for something like this, we can't assume that a house is built straight up and down. So now we need to identify what's our hypotenuse and what are our legs, just like we did in the practice problems. Drawing an arrow straight out, looks like 17 is my hypotenuse. That gives me my problem. Now I can go ahead and do 8 times 8 and 17 times 17, subtract 64 from both sides, and that gives me 225. If you don't know what the square root of 225 is, it's actually 15. Notice I put that feet thing on there because in the original problem it calls for feet. You want to make sure that if there is a unit of measure, feet, inches, centimeters, pounds, anything, you have that in your answer. It's very important to most math teachers, and in any practical application where you're in the real world, of course you would want to have units of measure because you're talking about real things in the real world. Okay, a second example. Christina walks to her bus stop on the other side of a field by heading east 40 feet and then turning south and heading 30 feet. If she cuts across the field, how far would the walk be? So again, we've got a picture. Imagine a field. Okay. What we know is that if she walks this way, it's 40 feet. That's east. If she walks south, that's 30 feet. What we want to know is if I were to walk straight across the diagonal, how far would that be? Okay, so again, labeling a picture really helps. I don't know how people can just look at that word problem and just throw it on the paper as an equation. I know there are people out there that can do that. That's not me. So I like to draw a picture, so I encourage you, especially if you struggle with this, to draw a picture. So where's my 90-degree angle here? Well, we're assuming again that a street corner, is going to be a square shape. So again, 90 degrees. Sometimes we don't want to make these assumptions, but obviously in this problem we need to in order to solve it. So at this point now, I'm just going to draw my arrow straight out. That tells me that x is my hypotenuse. So my legs are 30 and 40. 40 times 40 is 1600. 30 times 30 is 900, which gives me 2500. If you take the square root of that, you're probably a little confused, but if you do know the square root of 25 is 5, so that would be 50 feet. Okay? So in class, we're going to do some more examples like these where we practice sort of these word problems soon. But for now, these will be a couple of examples to look back on in your notes when you have issues. The last thing we're going to talk about is some special triangles that we can memorize. And the purpose of that is, with right triangles, there isn't a whole lot of them that work out to be neat numbers. But a lot of times on tests and stuff like that, we end up using the same ones. So what we're going to do is we're going to memorize a few triangles, and I have some spots in the notes for you guys to do that. And those triangles are going to help us out. So first one, 3, 4, 5. Very common, most common of right triangles is a 3, 4, 5 right triangle, meaning one side's 3, one side's 4, one side's 5. Obviously, 5 has to be the hypotenuse because the longest side is always the hypotenuse. But what we know about these triangles is basically if we take all of the sides and we multiply them by something, the same number, it'll work. So let's say if I take all 3 sides and multiply them each by 2, like this, then that still makes a working right triangle. 6, 8, and 10 form a nice right triangle. And if you remember, that's the first one we looked at way back when. If I multiply it by 3, same thing. 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. That still makes a working right triangle. So what you can look for is you can look for multiples of 3, 4, 5. Okay, next, here we have it multiplied by 7. Multiplied by 10, and multiplied by 15. So if you're confused in the notes, what I was looking for you to do is basically, draw an example of 3, 4, 5 and list some other ones on the side that would work, or draw small pictures to match up. Okay, so now what we're going to do is we're going to kind of use that to try and find the missing side, just so you can practice it. This doesn't necessarily need to be in your notes, but if you have room, you can feel free to put it in there. What I want to know is here, this is a 3, 4, 5 right triangle. So what are the missing sides of the 3, 4, 5 right triangle? Well, what I'm going to do is I'm going to identify that this is 5 times 6. This is 4 times 6 on the left side. So that would mean the top one, if it's a 4, a 5, this would have to be 3 times 6, which is 18. Okay, looking here. We know that the hypotenuse is missing, so the other ones would have to be 3 and 4. And if you notice, you've got 3 times 9 is 27, 4 times 9 is 36, so the hypotenuse would have to be 5 times 9, which is 45. Okay, so here we go again. Notice that the hypotenuse is 5 times 8. The leg that we have is 3 times 8, so the last one would have to be 4 times 8, which is 32. And again, this is, you can still use a Pythagorean theorem, leg squared, hypotenuse squared. But since these ones are so common, I like to have my students memorize them just so you can use it as a resource. You don't have to. You don't have to use it. You can always use the Pythagorean theorem. But if you like to kind of find those little shortcuts and tricks and ways to memorize a few things that help you get through it, this is nice to do. Okay, so again, here we've got 3 times 11, 4 times 11, so 5 times 11 must be the hypotenuse. All right, the next one we're going to look at is a 5, 12, 13. That's another very common right triangle where one side is 5, the other side is 12, and the hypotenuse is 13. So on the notes, my intention is that you draw this under the part that says 5, 12, 13 right triangle, and then on the side you can list other right triangles or you can draw the pictures. It's up to you. So again, I can go ahead and multiply by 4 on each of them, multiply by 5 on each of them, multiply by 10. So I'm just showing that no matter what you do, as long as you multiply all 3 numbers by a constant, some number, then it will work out. Okay, the last one we're going to talk about is 8, 15, and 17. Again, you don't have to memorize these. I like to offer it to students because a lot of times you'll see the same problems on tests, but it's not absolutely necessary. You can use the leg squared, hypotenuse and be just fine. So if I multiply all 3 by 3, 5, and 8. Similarly, we could find missing ones using practice, but I'm going to go ahead and save that because the numbers start getting pretty large. So basically what I want you guys to do, that kind of sums up our notes here. I want you guys to complete your notes and take the little poll down below so I know you've taken it, and that you can go ahead and let me know any questions you had with the videos. So thank you, and I'll see you guys tomorrow.